Hi everyone. In today's question, we are asked to calculate the area of this quadrilateral ABCD. We have the length of this side AB to be 11 units and the length of this side CD to be root 56 units. We have the radius of the circle to be 4 root 2. We have the size of this angle ABD to be A, and similarly the size of this angle CBD is also A. That means the angles are congruent. So how can we solve this? It is very simple. Look at this chord CD. We have its length to be root 56. The formula for calculating the length of a chord is 2r sine 1 over 2c. So line CD equal to 2r sine 1 over 2c. The length of line CD is root 56. R is the radius which we have here to be 4 root 2. And C is the central angle of the sector containing chord CD. That is the angle this chord subtends to the center. We don't have it, but we can see this angle A is subtended by chord CD to the circumference. From the circle theory, there is a rule that the angle at the center is twice the angle at the circumference if subtended by the same arc. So since C is the angle at the center and angle A is at the circumference, by this rule here, C equal to 2A, we substitute it here. So root 56 equal to 2 times 4 root 2 times sine 1 over 2 times 2A. 1 over 2 times 2A is 2A. Here 2 times 4 root 2 is 8 root 2. So root 56 equal to 8 root 2 sine A. Transposition now. 8 root 2 sine A equal to root 56. Divide both sides by 8 root 2. Here 8 root 2 cancels 8 root 2. While here root 56 over 8 root 2. 56 is 28 times 2. 28 is 14 times 2. 2 times 2 is 4. Square root of 14 times 4 is square root of 14 times square root of 4. Square root of 4 is 2. Root 14 times 2 is 2 root 14. This 8 is 4 times 2. This 2 cancels this 2. This 14 is 7 times 2. Square root of 7 times 2 is root 7 times root 2. This root 2 cancels this root 2. So sine A equal to root 7 over 4. Keep it aside. Now assuming we have a right angle triangle with one of its angles to be the same size as this A, using the circle tool on the triangle, take this angle as theta. This is the opposite, this is the adjacent, and this is the hypotenuse. From here, sin theta equal to opposite over hypotenuse. Theta is A, so sin A equal to opposite over hypotenuse. Recall here, sin A equal to root 7 over 4. Substitute here, so root 7 over 4 equal to opposite over hypotenuse. From this equation, we can obtain that if opposite is root 7 units, the hypotenuse will be 4 units. That is, this opposite is root 7 and this is 4. Now since this triangle is a right angle triangle, we can use the Pythagorean theorem. The hypotenuse is the side facing the right angle, which is this here. The square of this 4 must be equal to the sum of the squares of this root 7 and the length of this side, let's say x. So 4 squared equal to root 7 squared plus x squared. 4 squared is 4 times 4, which is 16. Root 7 squared is root 7 times root 7, which is 7. So 16 equal to 7 plus x squared. Subtract 7 from both sides. Here 7 minus 7 is 0, while here 16 minus 7 is 9. So 9 equal to x squared. Take the square root of both sides. Here square root of 9 is 3, while here square root of x squared is x. So 3 equal to x. That is, the length of this side is 3 units. Now from the SOHCAHTOA, we know tan theta equal to opposite over adjacent. And from this angle, there is the opposite and there is adjacent. So theta equal to A, opposite equal to root 7, and adjacent equal to 3. Substitute here. Now tan A equal to root 7 over 3. We're done with this triangle. This equation also, we keep it aside. Look at this chord CD and this chord AD. They both subtend angle A to the circumference. We know in any circle, chords subtending angles of the same size to the circumference are equal in length. That is, this chord AD and this chord CD are equal in length. So since the length of chord CD is root 56, that means this chord is also root 56 unit in length. Now look at this chord BC. We don't have its length, so we assume it to be y. Now what we want to do is come here, draw a line from this point C to a point on this line AB. So we have a segment the same length as this, which is y. So therefore, the length of this segment is y. Now look at this triangle. We have the length of two of its sides to be equal in length. That is, it is an isosceles triangle. We can see this line bisects this angle, which is the vertex angle of the triangle, because it is the angle between the two congruent sides. That means it is an angle bisector of this triangle. And we know the angle bisector of an isosceles triangle, if drawn from the vertex angle, is also its median. That is, it bisects this side here. So this segment and this segment are congruent. Assume its length to be z, and the angle bisector is also its altitude. That is, this angle is a right angle. Now we come here, draw a line that connects this point D and this here. Look at this triangle. This line bisects this side of it, and it is also a triangle with the side. Therefore, it is a median of either an equilateral triangle or an isosceles triangle. So this triangle is either an equilateral triangle or an isosceles triangle. In both cases, this side and this side are congruent. So since this is root 56 units in length, this must also be root 56 unit. Now look at this triangle. The length of this side is root 56 unit, and this is also root 56 unit. This angle is the vertex angle. So if you draw the median of the triangle from the vertex angle to this side here, the side will be bisected. The median is at right angle. That is, this angle will be a right angle, and this segment will be congruent with this segment. Let's assume their lengths to be x each. Now look at this triangle. It is a right angle triangle. We use a Pythagorean theorem. If you assume the length of this side to be v, by Pythagoras, the square of this root 56 must be equal to the sum of the squares of this x and this v. So root 56 squared equal to x squared plus v squared. Root 56 squared is 56. So 56 equal to x squared plus v squared. Take x squared to the left. So 56 minus x squared equal to v squared. We keep it aside. Now look at this triangle. Since it is a right angle triangle, we can use the SOHCAHTOA. Taking this angle as theta, this is the opposite, there is the adjacent. We know tan theta equal to opposite over adjacent. Theta is A, opposite is V, and adjacent is the sum of this y and this x. So tan A equal to V over y plus x, square both sides. Now tan A all squared equal to V over y plus x all squared. V over y plus x all squared is V squared over y plus x all squared. Now from here, 56 minus x squared equal to V squared. That is V squared equal to 56 minus x squared. So this V squared is 56 minus x squared. Here we have tan A equal to square root of 7 over 3. Square both sides. Now tan A all squared equal to root 7 over 3 all squared. Root 7 over 3 all squared is root 7 squared over 3 squared. Root 7 squared is 7 and 3 squared is 9. So tan A all squared is 7 over 9. We come here, replace tan A all squared with 7 over 9. So 7 over 9 equal to 56 minus x squared over y plus x all squared. Now look at this chord AB. Its whole length is 11 units, but it is divided into 3 segments. This segment which has its length to be y, then this segment and this which have their length each to be x. That means their sum will be equal to 11. So y plus x equal to 11. X plus x is 2x. We subtract x from both sides. Here 2x minus x is x. So y plus x equal to 11 minus x. We square both sides. So y plus x all squared equal to 11 minus x all squared. 11 minus x all squared, if you expand, is 11 minus x times 11 minus x, which is 11 times 11 minus x times 11 minus x. 11 times 11 minus x is 11 times 11 plus 11 times minus x. 11 times 11 is 121. Plus 11 times minus x is minus 11x. Minus x times 11 minus x is minus x times 11 minus x times minus x. Minus x times 11 is minus 11x. And minus x times minus x is plus x squared. Minus 11x is minus 22x. So y plus x all squared equal to 121 minus 22x plus x squared. We come here, replace this y plus x all squared with 121 minus 22x plus x squared, which we can say is x squared minus 22x plus 121. So 7 over 9 equal to 56 minus x squared all over x squared minus 22x plus 121. Cross multiply. Now 7 times x squared minus 22x plus 121 equal to 9 times 56 minus x squared. 7 times x squared minus 22x plus 121 is 7x squared minus 154x plus 847. 9 times 56 minus x squared is 504 minus 9x squared. So 7x squared minus 154x plus 847 equal to 504 minus 9x squared. 7x squared is same as 16x squared minus 9x squared. This minus 9x squared will cancel this minus 9x squared. Bring this 504 to the left. 847 minus 504 is 343. So 16x squared minus 154x plus 343 equal to 0. Which if you solve using the quadratic equation formula, x equal to 6.125 or x equal to 3.5. Now which is the right value for x? 6.125 or 3.5? If we test for x equal to 6.125, looking at this segment, its length is sum of this x and this x. So it is 2x. If x is 6.125, then that means it is 2 times 6.125, which is 12.25. The length of this segment is 12.25 units if x is 6.125. But we can see it is just a part of this code AB. The length of code AB is 11 units, which is less than 12.25, and it is not possible that this segment is longer than code AB. So x equal to 6.125 is not the right answer. Therefore, x equal to 3.5 units. We substitute here. Look at this code. It is divided into 3 segments, which are this, this, and this. And its whole length is 11. Therefore, the sum of this y, this 3.5, and this will be equal to 11. Now y plus 3.5 plus 3.5 equal to 11. 3.5 plus 3.5 is 7. Take 7 to the right. So y equal to 11 minus 7, which is 4. So y equal to 4. That is, the length of this segment and this code is 4 units. Now from these details here, can you calculate the area of the cyclic quadrilateral without the use of a calculator? Please try and see your answer in the comment section. Thank you.